In this part of section 3.1, I want to talk about 3 rules for taking derivatives. So we've already talked about how to take the derivative of a constant and the identity function and how to use the power rule. So these 3 rules that we're going to talk about next are rules about combinations of functions. And so if you know how to take the derivatives of some parts, how do I take the derivative of functions that are built up from those parts using addition or subtraction or multiplication by a constant? So the first rule that we want to talk about is the constant multiple rule for taking derivatives. If I've got a constant and a function f, right, that's derivative, it has a derivative, then the derivative of the constant times that function, all I have to do to take the derivative is to rewrite the constant. I don't do anything to it. And then I multiply by the derivative of the function. Okay, so here's an example. Here I have a function f of x, and it's a constant, 3, right, multiplied by x squared. And I want to find its derivative. Okay, so here's what I do, right? This rule right here says just take the constant that you had, 3, right, and rewrite it because it's being multiplied by x squared, and then times by the derivative of x squared. So the derivative of x squared we already saw was 2x, and so that's it. If you've got a constant times a function, you want to take its derivative, just rewrite the constant and multiply by the derivative of the function, and that's it. Here we would simplify a little bit, right, and get f prime of x equals 6x. Okay, and so that's all there is to it on the constant multiple rule. So that works pretty nicely. Next up, we have the sum rule. Okay, and the sum rule says let f and g be differentiable functions. If I want to take the derivative of f plus g, all I've got to do is take the derivative of f and then add the derivative of g. So that's about as nice as you can possibly get. It makes sense, right? It works in a way that seems like, you know, that's the way that it should work. So, all right, so here's a quick example. If I have f of x equals x to the 4th plus x cubed, when I look at that, it's the sum of 2 functions, right? I add x to the 4th plus x to the 3rd, okay, and I want to find the derivative. So the sum rule says, right, all I've got to do is take the derivative of x to the 4th, and that's a power rule, right? So I would bring the 4 down and subtract 1 to get 4x cubed. So that's the derivative of x to the 4th. Then I would add the derivative of x cubed, right? And again, that's a power rule, right? It's x to some number power. So I would pull the new power down, right, and subtract 1 from the exponent. So I would get 3x squared for the derivative of that. Okay, and so that is the derivative of x to the 4th plus x cubed. So taking the derivative works really nicely with adding, and as we'll see next, also with subtracting. Okay. So the final rule I want to talk about is the difference rule, right? If f and g are differentiable functions and I want to take the derivative of the function formed by subtracting f and g, f minus g, all you've got to do is take the derivative of f and subtract off the derivative of g. And so it works, again, really nicely, as nice as you could want there. So, all right, so here is a function f of x equals x squared minus x. We want to find the derivative. So again, this is the difference of 2 functions. I've got a function x squared. I'm subtracting another function x. So the difference rule says just take the derivative of the first one, right? So the derivative of x squared is 2x. And then subtract the derivative of x. And the derivative of x is just 1. And so that's it. So again, it works about as nicely as you could ask for there. So, all right, so that's about it for this section. I'll have one more section where I'll talk about exponential functions and then some examples.